Okay, welcome back. So today we are going to talk about finding the area between two curves. And I've got kind of an example here that will help us build to the work that we want to do. So first we're asked to graph the function f of x equals -1/2 x minus 2 quantity squared plus 6. So I'm going to graph that on my calculator here. And you can speed up if you want to, but we've got -1/2 times the quantity x minus 2 squared plus 6. So we graph that. Probably should have deleted that other graph. We don't need this. And if I trace a few points here, at 0, I've met 4. Okay. And then it looks like maybe at 4, I'm at 4. Okay. And let's see. 2, 6, looks like it's about our peak there. Okay, so we can kind of graph that, something like that. And then we want to find the integral from 0 to 5 of f of x dx. Well, of course, that's going to be the integral from 0 to 5 of -1/2, that's a 5 there, -1/2 times x minus 2 squared plus 6 dx, which is going to become a -1/6 times x minus 2 cubed plus 6x evaluated from 0 to 5. So that's going to give us -1/6 times 3 cubed plus 30 minus a -1/6 times -2 cubed. So we have -27/6 plus 30 minus 8/6, which gives us 145/6. Great. All right, we've got a number there. And we're asked to shade that region in blue. Okay, so I'm going to shade that entire area. Well, from 0 to 5, so we started 0, we went to 5, that's going to be this, right there. That's going to be all of that space. Well, now we're asked to graph g of x equals 4 minus 1/2. Okay, so I'm going to go here, and we have 4 minus, what did I say it was? -1/2 x. So we're going to graph that. If I trace here at 0, I'm at 4. That's kind of cute. At 2, I'm at 3. At 4, I'm at 2. And at 6, I'm at 1. Looks like at 8, I'm at 0. 5. I don't know why that happened, but anyway. So my line looks something like this. Okay. All right, hopefully you can see that. And we want to find the integral from 0 to 5 of g of x dx. So that's going to be the integral from 0 to 5 of 4 minus 1/2 x dx, which equals 4x minus 1/4 x squared, evaluated from 0 to 5. That's going to give us 20 minus 1/4 times 5 squared, which equals 55/4. And we're asked to shade that region in green. Okay, well, and I actually do have a green pen. One moment here. Okay, we are asked to shade that region in green. Well, from 0 to 5, we did this. Okay, right there. Well, that was all of this space from 0 to 5. Is that 5? This is 5. Whoops. That's 5. Of that graph. Turns out I didn't graph all the way to 5 earlier. So we shade that region green. And then, how would we find this area between f of x and g of x? Well, all we're going to have to do, I don't know why this is crooked. All we're going to have to do is subtract, right? So we're just going to subtract g of x from f of x, right? The area of. Okay? But how would we find this algebraically? And that's kind of the question that we're going to be answering today. Well, in order to find this algebraically, we're still just going to use subtraction. So all we would do, that area between the two curves would be equal to the integral from 0 to 5 of f of x minus g of x dx. Well, let's actually do that. Let's see what kind of an answer we're going to get. So we would have the integral from 0 to 5 of negative 1/2 times x minus 2 squared plus 6 minus 4 minus 1/2 x dx. So that's going to be equal to the integral from 0 to 5. Well, here we'd end up having negative 1/2 x squared plus 2x minus 2 plus 6 minus 4 plus 1/2 x dx. We expand all of that out a little bit. So plus 1/2. All right. So this is all going to become the integral from 0 to 5 of 5/2 x minus 1/2 x squared dx, which of course we can evaluate as 5/4 x squared minus 1/6 x cubed from 0 to 5, which gives us, why is this crooked? Sorry, students. Which gives us 125 over 4 minus 125 over 6, which just equals 125 over 12. Okay? Great. So that's it. That's the area between the two curves. That's the area between, like that we're kind of double shaded over here, between our graphs f of x and g of x. Okay? All right. So let's move on here. We want to find the area of the region between the graphs f equals 14x plus x squared minus 2x cubed and g of x equals x squared minus 4x. Well, we could graph this, and actually, if I do graph this, I'm going to pause here while I graph these on my calculator. Okay, I graphed these, and so you can see here that this graph, this is going to be our f of x, is that cubed function there, and then here our g of x is that parabola, and we actually have two spaces here between, right? So we cannot just use subtraction easily, because in this case g of x is on top. We'd be subtracting g of x, f of x from g of x, but here f of x is on top. Well, it would be f of x from g of x. So the first thing that we need to do is actually find the points of intersection here so that we can set up our equations properly. So what we're going to do first is set 14x plus x squared minus 2x cubed equals x squared minus 4x, all right? So that's going to give us 2x cubed minus 18x is equal to 0. Take out a 2x, we're left with x squared minus 9 equals 0. So x is equal to 0, 3, and negative 3. And I'm going to go back to my calculator and just check, is that accurate? So if I go here, I trace at 0, it's 0. At 3, it's, negative 3 right there. At negative 3 is 21. You can't see it on here, but it looks like we're pretty accurate there. So now we actually need to write our integrals. And so I'll just draw a quick sketch of what this looks like. This is not accurate. But here, this is our g of x, right? And this is our f of x. So our first integral, this was at negative 3, right? That's at negative 3. This is at 0. They're supposed to intersect there. This is such an ugly graph, but hopefully you understand what I'm doing here. And this is 3. From here, we're going to take from negative 3 to 0. We want negative 3 to 0. We want g of x minus f of x, right? dx. And then we can call this our area 1. A sub 1 equals. And then a sub 2, we're going to want, because this is our f of x, we're going to want the integral from 0 to 3 of f of x minus g of x dx. Okay? So let's actually work that out now. I don't know why this keeps getting crooked today. It's so annoying. All right, so our first area is going to become the integral from negative 3 to 0 of x squared minus 4x minus 14x plus x squared minus 2x cubed dx. If I were you, I would be speeding up through this part. These are going to cancel out. Negative 4 minus 14 is going to be negative 18x. So I did that. minus a negative is plus 2x cubed. So that will give me negative 9x squared plus 1/2 x to the 4th from negative 3 to 0. So that's going to be 0 minus 0 minus negative 9, 81. Negative 9 times 9 is going to be a negative 81. Plus 3 to the 4th is 81. So 81 halves. So that equals 40.5. Okay? So that's the area of our first section there. And then the area of our second section is just going to be the same process but backwards, right? So 14x plus x squared minus 2x cubed minus x squared plus 4x dx. We're going to have 18x. Those cancel out. Minus 2x cubed. Yep, dx. So you have 9x squared minus 1/2 x to the 4th, 0 to 3. So this will become 81 minus 81 halves minus 0, which equals 40.5. So now, what's the total area here? Well, our total area is a sub 1 plus a sub 2, which equals 40.5 plus 40.5, which just equals 81. Okay? So the area between these two curves was equal to 81. All right, pause for a second here.